In August 2024, Chinese electric vehicle or EV brand Zeekr announced that its newest sedan, model 007, will be delivered with 5.5C charging. This means that the battery pack on the vehicle can go from 10 to 80% state of charge or SOC in just 10.5 minutes. Zeekr did not just stop there. The company further claimed that the new battery pack on the model 007 would deliver an equally good charging performance at 14 Fahrenheit and reach 80% SOC in just 30 minutes. Zeekr's move is likely to start a new charging race among EV manufacturers as they race to address charge anxiety among EV owners. But this new race is likely to bring to the surface the power problems of the EV battery industry at large, where vehicles do not deliver as promised and EV manufacturers have little control over what a battery can do. Here's a deep dive into the most important component of an electric vehicle: the battery pack. Even before commercially made EVs arrived in the market, the term range anxiety already had. Unlike their fossil fuel counterparts that can be refueled almost anywhere on the planet, EVs and their manufacturers had to address the ominous question of how far could they go on a full charge. This was dubbed range anxiety, and the term accompanied all news of EV launches till the likes of Tesla began delivering 300 miles plus on a single charge. Other EV manufacturers did not stop there and promised the moon to potential customers by aiming for a 600-mile mark, but that brought in a different kind of anxiety into the picture. How long would the EV take to charge? Gas stations aren't popular just because they are ubiquitous these days. They are also popular because they refill the tank in a matter of minutes, and one can resume their journey in no time. EVs with bigger battery packs, on the other hand, needed longer hours of charging time. EV manufacturers did their best to install chargers at motels and hotels where drivers would rest for the night while the car battery prepared for another long haul. But planning these stops across the large network of roads for a single market alone is a logistical nightmare. The only logical solution was to speed up the charging time and reduce it to minutes. Fast charging technology made this possible, and its potential in driving EV adoption was felt on the ground in the form of supercharger networks being rolled out across the world. But the race to charge an EV the quickest did not stop there. Chinese EV manufacturer BYD successfully dethroned Tesla as the world's favorite last year and has also been working to launch its second-generation Blade battery, which promises 6C charging. This is BYD's first battery update in 3 years. C is the charging multiplier, so a 6C charger would charge a battery in 1/6 of an hour or just 10 minutes. This is faster than what Tesla's supercharger offers, and along the lines that Zeekr rolled out in August. But BYD isn't alone. Contemporary AmpereX technology, or CATL as it is popularly known, has also confirmed that 6C charging rollout in the second half of 2024. Last year, Greater Bay Technology announced its Phoenix battery for EVs, which it claimed could charge up in just 6 minutes. The company went further to announce that this fast charging could be achieved in any weather thanks to the battery management system that could heat up the battery to normal temperatures, even in extreme cold, before beginning charging. Last heard, Greater Bay Technology was setting up a manufacturing facility for its battery, but it was a far cry from being installed on an EV anytime soon. So this raises the question of whether numbers coming out of China can be relied upon. EV owners will be the first to warn against taking manufacturer figures about charging rates at face value. The numbers claimed can come true only when a large number of factors, ranging from battery charge levels to charger type to phase of the supply and number of users at a charging outlet, are all allied in favor of fastest charging. Even if these were to happen, the battery management system would take into account the quality of the EV battery before deciding whether it should accept peak power from the charger and for how long. This can vary the battery's charging time and even delay it. In some real-world experiments conducted by automobile websites, charging rates for BYD vehicles increased with consequent recharges in the same day, even doubling on some occasions. Another China-based supplier, CATL, is a prominent name in the battery supply chain, and its battery packs power Tesla, BMW, Hyundai, Volvo, and many more brands in the EV space. This company rolled out its 5C charging capability through its Qilin battery with Li Auto's Mega MPV earlier this year, where users can get 310 miles of range in just 12 minutes. Having experienced the quality of battery technology from CATL, one can rest assured that the numbers are backed by some evidence, even though they might not be realistic in most scenarios and need to be taken with a pinch of salt when they are announced. What one cannot dismiss is the dominance of Chinese companies in the space, with R&D and production housed largely in China. By keeping battery development in-house, BYD and Zeekr have also gained a technical advantage over other EV makers who are now reliant on CATL's developmental pace to compete with the Chinese brands when it comes to the important component of an EV, the battery pack. BYD's foray into European markets has stirred up another controversy between China and the West. At $10,000, the company's small car offering Seagull is Europe's cheapest EV, undercutting prices of other EVs by as much as $50,000. This has spooked automobile manufacturers in Europe, where EV adoption is on the rise. The company maintains that embracing technologies at scale helps it keep its costs low. For instance, BYD skipped lithium-ion batteries and chose lithium iron phosphate or LFP batteries instead to reduce its manufacturing costs. However, automakers believe that the company enjoys higher subsidies for its manufacturing in China and is therefore able to price its products cheaply. In the US, the government has imposed a tariff on any EV made in China in a bid to dampen demand for EVs made overseas. For a vehicle priced like Seagull, this would still not raise the prices at par with US-made EVs and could result in higher tariffs being imposed on the vehicle when it launches in the US. In a tit-for-tat move, China could raise tariffs on battery packs exported from China, which would further increase the costs incurred by EV manufacturers based outside of the Asian country. This has stoked fears of slowing down demand for EVs and thereby the transition to a cleaner mode of transportation. The turn of events in the EV battery markets are similar to what has unfolded between China and the West in recent years over technologies such as artificial intelligence, semiconductor chips, rare earth elements, and even nuclear reactor technology. China's rise as a technology behemoth in recent years, along with its military ambitions, has put it on a collision course with the US position in global politics. China's choice of allies and race to become the global superpower makes a friendly relationship with the US quite untenable. The interdependencies of global supply chains and commerce mean that the US and China are highly dependent on each other. However, due to geopolitical tensions, they find themselves just one major move away from snapping ties. In such a scenario, the EV industry in the West needs a reliable source of batteries to power the energy transition. This is where other battery suppliers come in. Just around the time Zeekr announced its Model 007's rapid charging times, South Korean electronics major Samsung announced that its pilot solid-state battery production line has come online and that the company aims to produce all solid-state batteries by 2027. The South Korean giant also confirmed that it had sent test batteries to EV manufacturers that could deliver a 600-mile range but charge in just 9 minutes. Samsung has also followed in CATL's footsteps and aims to deliver a battery with a 20-year lifespan. Samsung's Japanese counterpart, Panasonic, has worked with Tesla on EV batteries using lithium-ion technology. Last December, the company announced a battery pack that can be charged in 10 minutes and delivers a 500-mile range. It is important to note that Panasonic's offering is for EV manufacturers keen to use Li-ion battery technology. The advancement in charging times is attributed to the silicon powder anode, which will be manufactured at a facility in Washington state in the US to reduce dependence on China. From these efforts, it is clear that sub-10-minute charging times are within the realm of reality for EVs, and sooner or later, every EV sold will practically be charged for a run in just about the time needed to tank up a vehicle with an internal combustion engine. The question is whether this can be achieved without being completely dependent on China. It is abundantly clear that Samsung and Panasonic are actively working to reduce the Chinese dominance in the battery supply chain with a short to medium-term outlook. While the company's long-term R&D efforts will look to oversmart their Chinese counterparts, Swedish firm Northvolt is a few steps ahead of the market and is focusing on the sustainability of EV batteries by making batteries from previously used batteries. While this might sound counterintuitive, Northvolt is achieving this by tapping into the recyclable nature of elements used in batteries. As demand for EV batteries grows, it will also increase the demand for components which can only be met by mining them out of the ground. Not only does this beat the purpose of an EV transition, but also brings back a problem EV makers are wary of: China. Even the supply of elements needed to make batteries is controlled by China. The Asian country either owns vast reserves of minerals or has tie-ups in countries that own them and process them for global industrial usage. In such a scenario, Northvolt's approach can recycle used components and reduce the dependence on China for new batteries. The company is building a facility in Sweden that can recycle 125,000 tons of batteries every year, scaling up battery recycling to industrial levels. Although it began its industrial journey with mass production, China has quickly superseded its place in the global supply chain as a technology provider as well. In the case of EVs, it is the Chinese innovation that is determining the pace of evolution in the industry, while also tightly controlling who is in the lead. China's political ambitions have also set it on a collision course with the US, and the fallout of a geopolitical dispute could have deep ramifications for the EV industry at large and the plans to move away from fossil fuels. To avoid major setbacks in this journey, the battery industry needs a course correction, moving away from Chinese dependence while also demonstrating innovative leadership. Only then will it be able to power through a tough period or risk a major discharge in the years to come.
Remember to hit the subscribe button and ring that bell to stay updated with our latest content. And while you're here, why not check out another one of our exciting videos? Thanks for watching, and see you in the next one.